We got another one coming up after this. So for those, let me introduce myself. My name is Erosion. I work here at WGR Southwest. I'm a qualified industrial stormwater practitioner, someone who's trained in helping people with the industrial general stormwater permit. And this is the first of 3 workshops I'm doing today. Rebecca will remind you, but I just want to let you know that they will be recorded and they will be on the website. My understanding is within about 24 hours after we record them. So that way, anybody who would like to, who can't make it today, they can come back to the website later and they can be, they can watch it. And I also created a certificate that you can fill out for proof of training for either if you participate today or if you watch them later on, you can do that. Or you can, and also I have the PowerPoint slides on the Stormwater Awareness Week website, so that way you can get these slides as well. So we try to make everything available for everybody. So let's get started. So the subtitle is where is basically the industrial general stormwater come from, who's required to have it, and what are these BMPs or best management practices? Why do we have to comply with it? So what I like to do is I like to see people on a history tour, because many times I have clients or I have people who come in and they get notification that, hey, we're supposed to have something with stormwater. What's going on? What's this all about? Why are we here? So let's kind of just do a little minor history. Back in the late 60s, early 70s, a lot of pollution in the waterways of the United States. And so what happened was one day at the Cuyahoga River, they had the media out there, but this is back before the days of internet. I know for some people that's like bizarre to think about that. But for us old folks who can remember days before the internet, it was like that. Well, they had the media out for something, and they saw that the river itself, the Cuyahoga River, actually caught on fire. There was so much sludge, stuff, the river was dead, and this layer of sludge would often, and more than one time, would catch on fire. And so there's this very famous, iconic picture you can see here of them pumping water from one part of the river, trying to put out the fire that's from the sludge that's floating on the other part of it. And so because the media was out there, they actually saw it. So it finally prompted the government to come up and to revamp an old environmental law. And from there, from all that situation, eventually came the Clean Water Act, came the EPA. A lot of things came from basically, this is really the spark, pun not intended, the spark that got the whole environmental movement as we have it today. And they found that the water was getting better, the rivers were getting better, the Cuyahoga River started coming back to life again, but they found that there was still too much problems in the water. So they revised it in the late 80s and came out with the MPDS program and the general permit program, which in California was started in 1992. And so this is a surface waters permit. In other words, water leaving your property, discharging, and going to the surface waters of the United States. Okay, so a lot of people ask me, wait a minute, if I have water in my pond, do I need to grab a sample? Under this permit, it is a surface water permit. Unless it leaves your property and goes to the waters of the United States, you're not collecting the water under this permit. Now, not to say you're not supposed to contaminate groundwater, but I'm talking about just about this particular set of regulations. It's a surface water permit. You're supposed to grab samples as water discharges. So the MPDS program was created, and it requires the development of a stormwater pollution prevention plan and monitoring implementation plan, which we put into one binder. So basically, you have this rather massive, let me show you, I have it here. You have this rather massive general permit, which is pretty much this part of my binder is pretty much the permit right here. Then the rest of it is my other, I call my compliance Bible stuff. But basically what that does is, basically it says in sections 10 and 11, you need to create a plan to help get to, so people, when people see their stormwater pollution prevention plan, their SWEP as we call it, they go, well, here's my permit. Well, no, actually that's the plan the permit requires you to create. So under the general permit, we have in sections 10 and 11, we have the SWEP section and you have the monitoring section. And right now in this thing, we're going to talk about section 10, which is the SWEP section. Okay. So what's in the SWEP? If I can get my thing to advance. There we go. All right. Now, you'll notice that across it, let me back up just so you see that. See across it says not certified by clerk. Well, people see that and say, oh, okay, well, I guess this isn't the official one. Well, actually, it is. The permit that we are under now, the amendments were voted on back on November 6th of 2018 and approved. And even though it says it's the unofficial draft, this is the enforceable permit. Right now, the reason the unofficial one is still being posted is they haven't assigned an official order number to it yet. The water board clerk has to assign a number, which hasn't happened yet. So while it says unofficial draft, it is the enforceable permit, and you're required to follow its regulatory requirements as of July 1st of 2020. So let's talk about BMPs. People hear the term BMPs, okay? And here's a textbook definition that we got. It basically says scheduling of activities, prohibitions, practices, maintenance, procedures, and other management practices to prevent and reduce discharge of pollutants. And it goes on. And you can see requirements, software procedures. Okay, that's the official definition. But I like to put things in English since I'm a simple guy. So let's say basically anything you do or practice or anything you build to reduce or eliminate pollutants in stormwater. Okay, so bottom line is that makes it a very broad definition. So if I'm sweeping the floor to get pollutants off the floor, that's a good housekeeping BMP. If I do my inspections, that's a BMP because I'm doing my observations. If I build a roof to protect stuff from touching, coming in contact with water, that's a structural BMP. So record keeping, sweeping the floor, and building structures are all BMPs, just different types. So as you can see, a BMP is a very broad definition. And what you'll find is some of the most effective BMPs are procedures. Well, why is that? Because if you do things a certain way, there is a better chance that if you follow a certain practice, you're less likely to get stuff into the water. And if, for example, if you can keep pollutants from coming in contact with stormwater in the first place, it won't be there when you have to grab samples. So that's important. So let's talk about BMPs. Well, as of 2015, what happened was we had a permit that came out in 1997. It lasted for 18 years. And then they revised it and came out with the one that's pretty much what we have now. This was amended, but a large part of this amended one was basically in place as of July 1st of 2015. And from that point forward, since 2015, we had what we call minimum required BMPs. So these are the BMPs that everybody is required to the extent feasible, and we'll touch on that. And also the advanced BMPs, which are primarily structural ones. Basically, again, you see the term to extent feasible, and that's important because when they were developing this permit, a lot of people were saying, listen, some of the things you're asking us to do are just not reasonable. I heard an argument when they were first doing the conversations for the permit back in 2014, 13 and 14, for the permit that came in effective as of July 1st of 2015, they're saying, listen, we have a stream that comes through our property. We had to grab samples from it because all our water goes into that stream. We did samples. The water coming into our stream is dirtier than the water leaves, but yet you're expecting us to meet certain regulatory requirements that water coming in is not good. So they had a hard time separating their water from outside water, which is always a challenge. But basically, they're saying we need to be able to put stuff in place. We have some things that are unreasonable. And so that's why they put the extent feasible. In other words, you need to apply the minimum BMPs to the extent feasible. And so BMPs consist of mostly non-structural practices, and under the current IGP are required to be applied to each facility. Okay, so you have to do these. Now, one thing that you will notice about these is you have to do good housekeeping. But it doesn't prescribe to you exactly what how you're going to apply the good housekeeping. Now, it goes in 3 pages explaining what good housekeeping is, and does give you a lot of guidance, quite a bit. That's why I went to over 208 pages of forms on this. But it doesn't say you have to sweep 4 times a day, or you have to power wash this. No, it says you need the good housekeeping, and then it kind of gives you categories and explanations of good housekeeping. But how you apply the good housekeeping is what you describe in your stormwater pollution prevention plan, your SWEP, okay? And for example, if there's a minimum BMP that if for whatever reason you feel is unreasonable, and you can make a what we call a red face argument. In other words, you can make an argument where you can keep a straight face and say, hey, this is reasonable. And if you can apply it to the extent feasible, you need to. If you can't do it to the extent that the permit's asking, you need to explain why and put it in your SWEP. So to the extent, as the permit says, to the extent feasible as requiring discharges to select and design, install, and implement BMPs that reduce or prevent discharges of pollutants and stormwater discharges in a manner that reflects best industry practice, considering technological availability and economic practicability and achievability. In other words, you need to apply this the best way you can. They say you need to do good housekeeping, you need to do preventative maintenance, you need to do these things. You're required, they are minimum, they're required. And you need to apply them to the extent feasible. If it's not feasible, you need to tell us why you say it's not feasible. But you need to apply them to at least the extent feasible for you. And again, if you don't apply them the way the permit spells out, then you need to explain in your SWEP why. And the water board can accept it or say, no, we want you to do more. In other words, how you implement the minimum BMPs needs to meet with what your industry is doing in general and what's technologically and economically achievable. So in other words, if I do a certain type of business and there's another business that's a competition of mine that's doing the same thing, if my numbers are good and his aren't, they're going to say, okay, what are you doing? And then they're going to look at him and say, hey, how come you're not doing what they're doing? It's feasible for them, so why aren't you doing it? So basically what they're saying is, if my industry in general has certain BMPs are doing and they're working and they're helping to keep water within the regulatory requirements, then that's going to become the expectation for everybody. It's achievable. It's technologically achievable. It's not saying they're expecting you to have the U.S. enterprise come down and land on your property and clean your stormwater for you. I mean, that's not feasible technologically or otherwise. But you can sweep. You can pick things up. You can put berms up. You can put covers up. You can. There's different things you can do to help keep you in compliance with the permit. So let's talk about the good housekeeping BMPs. First of all, you need to observe all outside industrial areas, including potential pollutants from off-site sources or anything that might affect stormwater discharges to determine how best to clean areas. Again, this is a general stormwater permit. So just to back in a little history, we talked about this permit coming out. It is from the Clean Water Act. It's from the federal government. And they told the states, okay, states, we have this multi-sector permit, multi-sector being landfills, manufacturing, transportation, things like that, energy, power generation stations, different sectors, okay? And we're saying these sectors under these 4-digit codes, but each business has a 4-digit SIC code, Standard Industrial Classification Code. And they say basically this SIC code, these types of businesses have a higher chance of polluting. So we're going to put them in a category saying you require coverage. You're required to make sure that you put protection, BMPs, in place so that water that leaves your property leaves relatively clean, so you don't contaminate the receiving water where your water ends up. Creeks, rivers, streams, wherever your water ends up, your receiving water. That's where they want to make sure, because you are the protection, you are the treatment for that water leaving. So it has to leave relatively clean. It doesn't go to the sanitary sewer where it gets processed. It goes right out to the regular rivers and stuff. So the federal government said, well, we have a multi-sector permit, but we're going to tell the states, you need to carry your own program if you want. So the states have to apply and say, hey, we would like to run our own program. So California runs its own NPDS, National Pollutant Discharge Elimination System, its own NPDS program. And so that's why you'll see the general permit that you have, that you're under, it's issued by the state of California. So it's a California Industrial General Stormwater Permit, but it's backed by the Clean Water Act. So it's a state issued permit with federal backing. Okay, so with that being said, so now California can make things more stringent than the multi-sector permit, but they can't make it less. So if the federal government says you have to do something in this platform, for example, a couple of years ago, they said for pH, you have to sample pH within 15 minutes of collecting your sample. That became a federal standard that now the state has to adopt because they can't make things less standard. They had to make it as equal to or more stringent than the federal version. So this general permit is just that. It's a general permit. It says, hey, clean your place up. As you can see in this first one, it says observe all industrial areas, including potential pollutants from offsite sources. So, and then basically determine how best to clean the areas. It's not saying you have to sweep 15 times, or it's saying, okay, look at these different things within the minimum BMPs. How are you going to apply this? And then your stormwater pollution prevention plan from Section 10 of the permit says, here's how we plan to do our good housekeeping. Here's how we plan to do that. Okay. So for example, they tell you minimize trackout. Well, how do you minimize trackout? Well, there's different approaches. Well, you tell us how you minimize trackout. You tell us how to minimize dust generation. Make sure to expose equipment and vehicle wash areas are clean. You tell us what you're going to do to comply with that rule. Cover all storm materials that might mobilize pollutants during a storm event. Again, some of these are pretty straightforward, and it's really hard to make an interpretation. Others, you have wiggle room to say, here's how we plan to apply this. And that's what your SWEP is all about. Your SWEP is all about telling them how you plan to comply with these requirements to the extent feasible. Okay, so it's a general permit with general rules, and that's why everybody gets the same permit. Everybody gets the exact same permit. You just tell them in your SWEP how you plan to follow this permit. And if you go to do something that the permit, if you're not going to do something that the permit prescribes, you better explain why and have a persuasive argument, or else it's not going to be accepted. Good housekeeping, to continue with good housekeeping, because one of the most important BMPs is keeping the place clean, believe it or not. So contain solid or non-solid materials or waste, particulates, powders that can be windblown or washed away in stormwater. So contain it. How do you contain it? Well, you tell them. Prevent wash water from getting into stormwater runoff. Okay. Well, yes, that's a good BMP, but it's also an illicit discharge. If you wash off, especially fleet vehicles, if you wash them and it goes down the storm drain and leaves the property, that's an illicit discharge, and you can get in serious trouble for that. So you need to prevent wash water precisely. You need to prevent it, but at the same time, just realize that's an illicit discharge, and you can get in trouble for that. Minimize runoff from non-industrial areas to industrial areas. The idea here is basically they think wherever you do industrial activity, loading, unloading, manufacturing, whatever else, it's probably going to have a greater chance of pollutants on the ground that can be picked up and washed off by stormwater runoff. And whereas non-industrial areas, which, you know, a parking lot qualifies, though I've seen some parking lots that are dirtier than industrial areas, but parking lots or grassy areas or vegetated areas where you don't do any industrial activity, they're going to have a lot less pollutants. So what they're saying is, if possible, again, to the extent feasible, remember that comes in, try to minimize water from non-industrial areas washing through your industrial areas, because then what it's going to do is pick up all the pollutants from your industrial areas and then either overwhelm or circumvent your best management practices and it leaves your property. Minimize authorized non-stormwater discharges. Okay, so when we talk about non-stormwater, that's stuff other than stormwater. And there is certain stormwater that's allowed. There's some stormwater that's not allowed to leave the property. Okay, even if there is certain non-stormwater, for example, like irrigation, as long as it's applied properly, there's a lot of caveats. There's a lot of things you have to watch out for. You can't just let things leave. It has to leave relatively clean. There's a whole list of rules that in my regular training I kind of go over all that, but we don't have time in this format. But basically, water that's allowed to leave, they still want you to try to minimize that if possible. The whole point is, if you can have water that stay on property and soak into the ground, that's the best. If non-storm water leaves, well, is it something that's allowed to leave, or is it something that's not allowed to leave? Okay, and so that's why you have to make sure that you, when you see non-storm water, you're supposed to go ahead and determine where it comes from. And in part 2 of our training, we'll talk about non-storm water, and we'll talk about when you apply it and when you do these observations and the circumstances around that. Preventative maintenance. Okay, this one is basically identify and determine all stationary equipment and mobile equipment and systems used outdoors that may cause or spill. So look at your stuff. What do we have out here? Okay, what can be causing a spill? And you'll find some of these BMPs, by the way, they overlap. Especially when you get to spill prevention and control, you'll see some of that too. You need to determine, again, the whole point is, you'll see, especially since the permit came out in 2015, they wanted you to take a look at your program. Don't just let things go by. You need to actually think through, because stuff you do does make it to the storm drains and does cause issues with pollutants in the water. So they want to say, okay, you need to think through this. What do you got? What can link? And how can we make sure that we do preventative maintenance to keep this from happening? The whole point is, if you maintain your equipment and your BMPs and your stuff outside that can have a leak or spill, it's less likely to have a leak. For example, I have a former client who had a whole bunch of old forklifts. This is out in the south of the Bay Area, out that direction, down towards, not quite far as Gilroy, but that towards that direction, down that way. And what happened was, this manager had a whole bunch of old forklifts that he never did any maintenance on, and basically whenever often the hydraulic hoses would leak and bust, and his idea of maintenance was put duct tape on it and get to it later. Okay, well, first of all, that's incredibly unsafe, and I'm sure that violates several OSHA rules, I'm sure. But basically, a new manager came in and said, "Oh no, you can't do this. This is not proper." So he called in a service one, and they had to service all the forklifts. And I noticed that over time, the yard went from being just a stinking mess to being relatively clean, and all the hydraulic oil spills that I saw all over the place that constantly had to be cleaned up were less. He actually did what they said. He performed appropriate scheduled maintenance, and he developed a procedure. Basically, his procedure was he scheduled with the maintenance place to come out once a quarter and do general maintenance on his forklift. So just that one procedure alone caused a massive positive change in the amount of pollutants that were hitting the ground. Spill and leak prevention and response. I call this a two-sided coin. Why? Because you have the idealistic side, spill and leak prevention. Let's keep spills and leaks from happening. Okay, but then we need to flip the coin over and realize that there's reality and things happen. Sometimes things just happen. I mean, no matter how well you plan, once in a while things are going to happen. So you have one side saying, yes, let's try to keep spills and leaks from happening. So let's develop procedures and controls to minimize spills and leaks. Okay, and let's train staff on spill prevention and response. But here's the other side, and response. So in other words, they know, okay, life happens, things happen. So yes, we're going to try to avoid spills and leaks, but then realize on the other side of the coin, well, but then things happen, and when things happen, how do you respond? Make sure that you have appropriate spill kit response materials and equipment. Okay, I had a client that they had these bays. I haven't worked with them in years, but they had these bays, and the maintenance bays were pristine, absolutely clean. And then they did was they took these giant 55-gallon barrels, these plastic ones, and they cut them about down 1/3 and had them all filled up with a K-liter type absorbent. And every time they'd work on a piece of equipment, if something spilled, they were real good. They had excellent Trackout control. I mean, nothing left that thing. The maintenance shop always looked clean. They always took time at the end of each shift to clean the maintenance bay. It was pristine. Problem was, they never took the time to make sure they restocked their spill response. Well, they had an old used oil container, and they had a forklift that came in, and it accidentally punctured their old forklift, their old oil tank, and the oil started spilling out into the warehouse next that was connected to the maintenance bay. And so they went to go get their spill stuff, and basically because they've been using all their spill response stuff all month or so, no one thought to go by and check on a regular basis and refill them up with spill response. So they had bags of it in a cage area, but the cage area was locked, and they had to go find a supervisor. And all this time, the spill's growing and growing and growing, and they put stuff as best they could, but all their spill response equipment was used up or in a caged area. Eventually, they've got a supervisor to unlock the cage area, and they were able to respond, but not before it became this huge mess. Good thing is it was actually a mess inside the building. It never actually left the building. But it was still a huge mess that shouldn't have been if they had just made sure that they had enough spill response materials on hand. So the moral of the story is, when you do your monthly inspections, which we'll talk about in part 2, make sure that one of the things you can include in that is take a look at your spill kits. Are they full? Do we need to fill them? Do we have enough response? Is there enough here? Make that a regular part of yours. That's why you'll see it says develop procedures. They want you to think through your program. Another minimum BMP is material handling and waste management. This is where I like to tell my clients, now you've become the expert. Okay, I can tell you what the permit says. I can tell you how the permit wants you to handle things. But many times, you, as what you do, you're the best person to tell me the best way to handle this so that it minimizes stuff escaping and getting off the storm drain. Now, many times I can make recommendations. For example, I had a client, I've told the story 100 times. I had a client who used Garnet water jet cutters, and they would fill up, and when the water jets, the garnet got too small, they would fill up in these giant tipping hoppers and take it out to a containment they had outside the building, which was a really good containment. But on the forklift, we would pick up these tipping hoppers, they'd fill them all the top, and as the forklift was bouncing and driving to the containment, it was splashing and getting metals, and their numbers were absolutely horrible in the stormwater. And no matter how much BMPs they put in place, it wasn't enough. They were going to have to go to a treatment system. And I said, well, in terms of material handling, why don't you just fill your hoppers 3/4 full or half full? Don't fill them all the way up. And so they did that, and immediately they saw an improvement to the point where they didn't have to put in a treatment control simply because they changed the way they handled their stuff. Now they had a nice place to secure and store their used garnet until it can get picked up by waste management, and they had nice clean ground, and things are better. So they had to maybe do an extra trip with the tipping hopper. It was worth it. Cover industrial waste disposal containers and industrial storage containers that contain industrial materials when not in use. Okay, this one here gives a lot of people heartburn because I have clients who've got several of these giant 40-yard bins, and they're like, wait a minute, these are supposed to be covered. And the bottom line is, yes, when not in use. If you have open containers and you close for the night and there's nobody there and there's no industrial activity, they're not in use. They're supposed to be covered. That's why, I don't know if many people noticed, but after 2015, a lot of facilities started getting those giant containers with the covers because people started demanding it, because now this is a minimally applied BMP. So they were like, oh, great, now I have to cover it. So many times people forget, when you have bins, whatever, you need to cover when not in use. And that's the general blanket rule. And I do have one client who found that to be unreasonable, and they had some other alternatives. But the bottom line is, unless you can really have a solid argument saying our alternative is going to work, you have to apply this. Erosion and sediment controls. Okay, now this used to be a lot bigger in just the construction permits, but as of 2015, when they first revised this permit to the kind of the location it is now, they added all this because basically the whole point is, and they noticed they put effective wind and rain erosion controls. So if you have big piles of stuff, I used to do inspections for the city of Stockton. I went to this one place where they had these massive piles of cottonseed. And the bottom line is there was no wind control, and every time the wind blow, all this stuff would blow out and just go all over the place. There was no erosion control or control for that. And I mean, these are small seeds that would get blown away all the time. I would think they'd want to protect that simply because it's part of their material stock. They want to keep in stock and watch their stuff they pay for fly away. But so they want you to think through this again. How can we keep wind and how can we keep rain from washing our materials that we stockpile from going away? I have a couple clients who work with sulfur, and they use walls. Some have walls that are completely around their sulfur piles. Some have walls that are in this section that protect from the wind side, where wind comes usually from the west, it heads east, or from the southwest to the northeast. They have walls on that section to help block the prevailing wind that comes through. So maintain effective perimeter controls and stabilize site entrances and exits to sufficiently control discharges of eroded materials. So that's why I tell people during a monthly inspection, which again we'll talk about in part 2, walk your perimeter. Make sure, because if water's leaving from somewhere, that's an outfall or that's a point of discharge you need to grab samples of, or you need to stop it or plug it. So what I make sure is, not only do you want to see water leaving, is there someone's water coming in? And if it is, you need to see if you can stop that or redirect it, or at least comment if you can't stop it. Say, hey, we have runoff coming from another source. So that's what you want to do. They want to make sure that some clients, they're an industrial site, but they look more like a construction site. I have ones who supply aggregates for the construction facilities, but they're an industrial site. So their site looks like an ongoing construction zone, when really in actuality it's actually an industrial facility. And so they had to put rattle traps down. They have to put barriers around their piles. They had to do things to keep their material from leaving the property. And so they want you to think through that, so that the solids don't get out into the storm drain. Remember, water leaving your property, they don't want it to wash off to the lakes and rivers and things. Employee training program. Well, for many of you here, in fact, for all of you here, by joining in this, and especially this one and the next one, you are actually fulfilling this training requirement, okay? because it requires you, the permit says you need to be trained and you need to be properly trained, okay? The old term was appropriate, which I have the word appropriate, but basically the term proper is also in the term. I had the word properly trained in there. And the bottom line is they kind of outline what they want you to train on, but they give you some wiggle room in how you train. So basically I just take all these things to permit that requires us to train, and I make sure I put that in my training. So kind of as a point back, I have, like I said earlier, when we first started the training, several people have joined us. So I want to recap. I have a certificate that you can download from our Stormwater Awareness website under resources, where you can download that and document that your training today. Also with that, I have these PowerPoint slides that you can download and print up, so that way you want to keep that with your stormwater pollution prevention plan to prove that, hey, look, we did our required training. We were trained by someone who knows the permit, because I am a QUISP. So at least theoretically, I'm supposed to know the permit. You can have that as proof of training. Okay. Now for dischargers who go to level 1 for parameter, they're required to be trained by a QUISP. So training doesn't have to be done by a credentialed professional like myself. However, if you are at level 1 for a parameter, which we'll talk about in the next section, but if you go to level 1 for a parameter, you will have to have a QUISP, someone with my credentials, train you. And you can talk about that more in part 2 of my upcoming workshop. Okay. Quality assurance and record keeping. In one sense, even under the old permit, the 97 permit, this was actually a mandatory BMP, because they required you to develop and implement track your procedures in a SWEP, to maintain your records on site for at least 5 years. So basically, this hasn't changed for probably since 92, but for sure since 97, when I started doing permit compliance. So this hasn't changed since 1997, where basically you need to make sure that you have a SWEP, stormwater pollution prevention plan, a SWEP, and make sure that you have your records up with, and you just maintain records for the last 5 years. And sometimes I've had regulatory bodies come on site and look for that and say, hey, I only see records for 2 years. Where's your 5-year record? Unless, of course, the facility is newer than 5 years. Now let's talk about advanced BMPs. So now we know the required minimum BMPs. Those are you're required to do those to the extent feasible, but you're required to do those. It also says you're supposed to do advanced BMPs to the extent feasible, but again, they know, especially for smaller facilities, putting in structural things can be a financial burden that's hard to cover. Okay, so let's talk about some of the advanced BMPs. Exposure minimization. This is a big one. And this is one of my favorite ones, because if you can get all your industrial activities under your roof, if you can keep all your industrial activities from coming in contact with stormwater, including venting on the roof, so you got to make sure that if you don't have venting on the roof, that can cause you an issue, because if you do, then this goes away. But if you can cover all your materials, if you can keep it under cover and prevent it from leaving either as Trackout or from venting on your roof, you can file for a no exposure certification, NEC, and be able to have permit requirements much more minimized for you. So make sure that you look at this. This is an important one. If at all possible, if you can put everything under cover, great. It won't get into stormwater. And if it's not in stormwater, when you grab samples, it won't be there. Okay. So number 1, exposure minimization. This is an advanced, covers, roofs, rain resistant shelters, things like that. 2, stormwater containment and discharge reduction BMPs. They like this one because it's the sister one to the next one coming up, which is treatment controls. Now, as of 2015, prior to 2015, if someone put a pond or they put a vegetative swell in their property, they say in their stuff, they say, I have a treatment control. Look, it treats it. Okay. But this permit came out as of 2015, and now again, as it's been amended, but it maintains this, that if you're going to call something a treatment BMP as outlined in the general permit, you're supposed to meet certain standards and needs to be certified by a professional engineer. And so they wanted to make a demarcation between that and just water containment and discharge reduction. But with that being said, they know that for a large segment of people, building an 85th percentile 24-hour storm is just not feasible than other property. But still, they say, hey, go ahead and build this. We want you to use this. Just because you can't call it a treatment BMP doesn't mean that you can't use it. Okay, so going back real quick. So basically, what I don't have in here and what I have in my other training is basically they actually have language in the permit that says we encourage you to do this. So if you can't put in an 80th percentile 24-hour storm, or if you can't put in a treatment system that can treat biologically, chemically, or physically stormwater that can accommodate an 80th percentile storm, 24-hour storm, still do it, because the water will still be cleaner than not. So I have a lot of clients where they have ponds. They've had ponds for years. And then when this permit came out, they say, oh no, do I need to have a professional engineer come in and have to spend all the money to have an engineer tell me whether or not well, no, not unless if your stormwater numbers, if you have discharges and your stormwater numbers go to level 1, level 2, then you might think about expanding that pond to meet that definition and having the work done. But until then, if your numbers are good, if your discharges are fine, and you don't have any reason to believe that there's an issue, then you don't necessarily have to have a professional engineer come in and engineer it. But you can still do it. You can still put ponds in. I mean, it's still good to put check dams in. It's still good to put vegetative swales. It's still good to have ponds that capture water to help solid. So there's a lot of advantages to putting stormwater containment and discharge reduction in. And one of the biggest advantages for you is if you put in a smaller pond, it may not meet an 80th percentile size, but it could capture maybe the vast majority of storms that we would have. For example, last year we only had 8 inches of rain. I mean, that for us, an average of 12 used to be. So many times, a lot of the clients who have ponds, they didn't have a discharge because even though their ponds weren't as big as an 80th percentile storm pond, they still didn't have any discharges because it just didn't reach the point to discharge because we didn't have a whole lot of rain. And that's better for you. If you don't have water leave your property, you don't have to sample. So many of them didn't get a lot of samples or any samples last year simply because it was a drought year and they have a small pond or they had ditches and stuff like that everything filled up a little bit, but it never actually left the property. And so that saves them headaches. You don't have to pay for sampling. You don't have to pay for the analyticals. You don't open yourself up to third parties who like to sue people on behalf of the environment, which I have my own opinions on that. But so there's a lot of advantages to doing this. Now, with that being said, if you can put in a treatment control that mechanically, chemically, or biologically can treat stormwater and can meet with the treatment control option or design standards outlined in Section X.H.1.6 of the permit, I say go for it. One, first of all, that will fulfill a lot of issues for you. And now with the compliance options, you might be able to apply this towards the compliance options that came out as of July 1st of 2020. But two, if you build an 80th percentile pond, you're likely not going to have a discharge or hardly ever have a discharge, which again, the water board likes that. Why? They want you to be able to capture water on your property to have it soak down to help recharge the water table. Because water used to be, people would just put down concrete and lay structures so that water would, instead of flooding, they were great at flood control, get it to the things and shut it out to the ocean. Problem is, our water table is dropping, water is not soaking into the ground, and all of the stuff that's being channeled, it's coming in at a high power, it's picking up pollutants and washing all these pollutants out into the storm drain. I used to live in Southern California, and every rain season, Santa Monica Bay is closed to swimming and surfing because the bacteria counts are so high and the hydrocarbons and things are so high because the water just washes off. And because of all of the existing infrastructure, a lot of it was built like in the 20s and 30s, but a lot of infrastructure just washes everything, gets water from the LA area and just washes it out of Santa Monica Bay. And they're not slowing water down, and it's just scraping up all the stuff and sending it out to the storm drains right out to the thing. So if you can do a treatment BMP and you capture the water, that's what they love. And if you can do it to the fact where you can have a professional engineer sign off on it and say, yes, this can handle an 80th percentile storm, then great, you got it, excellent. And you can put it in your SWEP, and also it can help fulfill certain, especially if you go to level 2, you're going to have to put in something more robust, like an 80th percentile storm. So that will help fulfill those requirements for level 2. So BMPs must be certified. To call it a treatment BMP, it has to be certified by an engineer, and I have all the references there for you. Okay. Now, here's the category, basically the other advanced BMPs. This is kind of like the category you throw in when you can't explain it anywhere else. The best way I can explain this, for example, is a lot of people nowadays, and we found at WGR that one of our often recommended BMPs is Filtrex filtering socks using compost media, because I found that it's pretty effective at helping to filter out water, and it helps improve water quality. So it does filter water. So in a sense, it's a type of treatment, but yet you're never going to be able to have it signed off to be able to handle an 80th percentile 24-hour storm. But it does, to a certain degree, have a certain amount of treatment aspect to it, especially if you get a sock that's got the metal absorbing material added to it as well. So even though I can't put the Filtrex socks under the treatment control BMP, I can't put them under the other category because, yeah, they are a BMP and they do help improve stormwater. And we have proof of that. We have some clients that have used Filtrex silt socks and their Metallox socks and their Enviro socks, and they work just fine. So that's where so for example, that's just an example. Maybe you have something else you can put in there. Some other BMP that works to help keep stormwater clean and doesn't fit those other categories, it will go in this category. So, I really flew through that. I was trying to pace myself because I want to make sure I make it. So we still have 15 minutes left on our workshop. Does anybody have any questions? Rebecca, I'd like to open up for questions, and I wanted to spend some time in interaction. I love getting feedback from people and see if I can answer questions. If it's specific to the point where I can't answer it, then maybe we can talk offline. But let's see if I can get some questions answered. So let's see.
Yeah, if you have any questions, feel free to unmute yourself and ask, or you can put them in the chat.
I was wondering if you could go over a little bit more about the difference between the stormwater containment discharge reduction and the treatment control BMPs. Is the treatment control BMPs, are you saying that only needs to address 80% of a 24-hour, or does it have to be 100%? I was just unclear about the differences between those two advanced BMP.
Okay, that's an excellent question. Okay. So containment control BMPs are BMPs that slow down or contain or slow down discharges, but doesn't meet the design standards outlined in the permit for a treatment control. Basically the standards outlined in the treatment control are in Section X.H.1.f of the permit. And let me back up to that slide so you can, let me see if I can back up to that slide so we can see the references for you. Basically, it has to be certified by a professional engineer, and they actually outline a couple of different references where you can where the professional engineer can do the calculations to show. And basically, it comes down to be able to handle an 85th percentile 24-hour storm. Now, I am not a professional engineer, nor I never claimed to be, but I did a little study on this, and from what it's my understanding. Again, someone please chime in if you have a better or a bit more technical term, but basically you have all the storms they've recorded for your area, and of all the storms they look at the biggest storms, and of those biggest storms they look at the top 85th percent. And so they're saying of the top 85% of all the biggest storms, they want to know over that water amount over a 24-hour period. So that's why an 85th percentile storm for Stockton is going to be different than one for perhaps Tracy or Gilroy or Redwood City, because the storms in your different areas have different things. So storm containment is basically if I build a pond, or if I build a trench, or if I build something to hold water, and it doesn't necessarily meet, nor have I done engineering to show that it can handle the 80th percentile storm or something equivalent to that, which that's the job of the engineers to make that determination based on the requirements in the permit. But if it doesn't meet those treatment control criteria in the general permit, I can't call it a treatment control, but I can call it containment. So I have a lot of clients who put ponds in their yards. They haven't done the professional engineering on it to show whether it can handle 80th percentile storm. It might, but they don't have the money or the inclination to go do the certification. Okay, Now, that being said, so anything that slows water down, even if it's for a short time, even if it's like a trench or something that holds on the water, something that helps to filter water before it leaves, it's not saying discharge. If you can completely stop all discharge, then you can apply for a NONA. A NONA is where you can prove that you can handle the largest storm in history in a series of storms leading up to the largest storm in history. If you can show that your facility can handle that vast amount of water and have a professional engineer sign off on it, you can get a NONA and you can get out of the permit altogether. Okay, so if you're going to collect 100% of your water, and you can prove it through a professional engineer's engineering specs, then you want to get out. You can get out of the permit. I've had a couple clients where they've had ponds big enough to qualify for that, but it's a rather huge area, and there are very few people who have the space or the ability to do that. We have one client in, I think they were in Tracy, and the road was on top, and they sat inside a quarry. The facility was inside an old quarry. It was no longer used as a quarry, but it sat inside a quarry. So basically, they were giant bowls. So basically, they said, "Hey, we bet this thing can handle a NONA." So we had a professional engineer come out, and sure enough, their facility sat down off the street, and it was big enough that it can handle the largest storm in history and a series of storms leading up to the largest storm in history. They were never going to discharge ever, and so they filed for and received the NONA, notice of non-applicability, the NONA, because they were never going to have a discharge, and it was professional engineer determined. Now, with that also, besides handling that, you also have to show that you're not hydraulically connected to the waters of the United States. So if you can hold all your water, but you have avenues where the water can escape and go to the surface waters of the United States, well, then you still don't qualify for NONA. But see, that's the good thing about these requirements. It's professional engineers whose job it is to determine whether you qualify for NONA. With that being said, I have clients where they build ponds that can handle 80th percentile ponds. We have one client in Stockton where I think it's the county, I'm not sure, but someone required them to build a 10-year pond. But when you look at the 10-year pond, from what the engineer was telling me, that basically the requirements for that 10-year pond were actually a little more stringent than the 80th percentile requirements outlined in the permit. So basically, by building a pond to meet the local municipalities requirements, they were also building it. It would also fulfill the treatment control BMPs as outlined in the permit. And so that was good for them, because now I said, well, what you want to do is, yeah, build your 10-year pond and have the calcs there, but you want to have your engineer also do a set of calculations based on the permit requirements showing that it fulfills the 80th percentile requirement as well. Does that help a little bit?
Yeah, it sounds like you could have the exact same BMPs for the stormwater containment in the treatment control, but if it's not engineered, it's not considered a treatment control BMP.
Precisely. You have to prove it. You have to have an engineer sign off and say, yes, this can handle an 80th percentile 24-hour storm. If an engineer does that, then you can call it a treatment control. I mean, you may have a pond or something that actually does that, but unless it's certified by an engineer, you can't call it a treatment control until you get the certification on that. That's an excellent question. Thank you. Did you have another question? Pleasure.
Looks like we have a question in the chat.
Yes.
From Kristen. Says, NONA only applies to surface water. If the pond filters to groundwater, does that still qualify for a NONA?
Yes. Groundwater, it's first of all, let's make sure we know you can't contaminate groundwater. So if you're contaminating groundwater, that's going to be an issue, okay? But if the NONA says you have to be able to handle the largest storm in history and a series of storms leading up to the largest storm in history, and two, you cannot be hydraulically connected to the surface waters of the United States. So this is a surface water permit. It's not a groundwater permit. Those are a different set of regulatory requirements. So if you build a pond big enough to handle that requirement and have a professional engineer say, yes, you're not hydraulically connected, and yes, you can handle that, which most engineers tell me it's not exactly. Most engineers tell me if you build a 100-year storm pond, you basically will meet that requirement. So if you have the site of this pond and can have engineers sign off on it and it doesn't leave your property, yes, that's it. Groundwater is separate from discharges to the waters of the United States.
if there are no other questions, I just want to follow up on the one about the treatment control. You're saying, are you saying the 80th percentile or 85th percentile?
85th percentile 24-hour storm.
Okay, and so that would infer that water could still leave the site. I mean, it's not the 100th percentile. So are you still required to sample if you have a treatment control if it runs off, or are you always waiting for that 100th percentile stormwater to run out and sample? Does that make sense?
If you don't use the compliance options, then yes, if you have a discharge from an 80th percentile, you're supposed to grab a sample.
Why wouldn't they just make it 100% percentile, and that way you'd be, I guess that would comply for a NONA.
Right, exactly. I tell clients, if you can qualify for a NONA, that would be the first thing I'd recommend they do, because that way they can get out of the permit altogether. Again, that being said, you're not allowed to contaminate groundwater, stormwater, but I'm talking about just in terms of regulatory. If you can build a pond large enough to hold a NONA amount, I say if you can, go for it. But if you can't, even if you build an 80th percentile, it's likely you're not going to have much or any discharges, because that's the whole point. It's 80%. It's a very large storm that would have to happen, or a series of storms, before you get enough to have that flow off site. And if your pond has really good infiltration, you may never have a discharge, but you'll still be in the permit. Because if you build the 85th percentile pond, you're still in the permit because you have the possibility of discharge, but will you have one? It's not likely.
Thank you.
Pleasure. I love questions. So anybody has questions, now's the time. I get a lot more questions on part 2, because that's when we talk about application, we talk about inspections, we talk about in part 2, we're going to talk about what the permit requires you to grab samples for, stuff like that, and we'll get more detail on that. But for now, if there's any other questions on BMPs or treatment controls or anything about the general permit. Well, maybe that wraps it up then. What do you think, Rebecca?
I think that wraps it up. Yeah, thank you so much, Aaron, and thank you everyone for attending. Like Aaron said, we have a part 2 of this workshop that starts at 11 a.m. and then part 3 is at 1:30 this afternoon. So be sure and join in on those. You can find the links on our website. But thank you all for joining. Have a great rest of your day.
Thank you. Thank you for all coming.